Hi, good afternoon, Introstat students. So today we're going to do another exercise from confidence interval unit, all right, unit 11. And the exercise should come from estimating a population proportion, right? Or population estimating a population proportion lesson. So we did the conditions for a z interval for proportion the last time in our last video, and just recap. The three conditions are, right, the samples have to be random, right, randomly selected, and normality. Right, the next normal condition is when n times p greater equals to 10, n times 1 minus, n times p hat, right? P hat is the sample proportion. N times p hat must be greater equals to 10, n times 1 minus p hat uh, must be greater equals to 10. P hat, by the way, p hat is a sample proportion. So and then the third condition is the independence condition, which is also sometimes known as the 10% rule. Independence condition is when the samples are independent from each other, or you can say that if the samples are if the samples are selected without replacement, the sample size has to be less than 10% of the population size. Anyway, with that said, was going to go to the next exercise, finding the critical value z star. Finding the critical value z star. Okay, so what is the critical value z star for constructing a 99% confidence interval? So, best thing to do is to draw a 99% confidence interval. So I'm going to draw, oh, my normal crowd is not very good. So 99%, right? If this is 99% from this interval, right? Z, so that would be a negative Z to a positive Z star, right? And here is 99%. Now, 99% is also known as 0.99, right? They mean the same thing. Now, this area here, right, because it's symmetrical, right, it's symmetrical, this area should be 1% divided by 2. And 1% divided by 2 is 0.005. And then this area is also 0.005. So if you add this and this and this, it will give you 100, or it will give you 1, which is 100%. So z star is this value here, right? And z star, negative z star and positive z star. So they are both the same value, but one is a negative, one is a positive because it's symmetrical, right? Symmetrical. So how do I find z star? How do I find z star? Now, there's a calculator function. Um, if you go to second vars, and so second, you press second, and then you press vars, and then you pick out number 3, right, which is the inverse norm, right? Okay, and if you're using the calculator app on your phone, it will ask you for 3 things. What are the 3 things? So the first thing is it will ask you for area to the left. That's why I always wanted to draw, because it visually you can actually tell. So area to the left of the z star. So area is here, right? Area is this whole thing. All right. So this is area to the left of this. Now, if this is 0.99, right? We don't put that percentage here. We put decimal. So 0.99, but we have to add this tail, right? This 0.005. So here, um, pick a different color. So here 0.99 plus 0.005 will be 0.995. And this is going all the way to negative infinity, right? Going all the way to negative infinity. But we don't need this. We just need the area to the left. So the area to the left of z star is 99.5, which is 0.995. And then here we need the mean, and we need the standard deviation. Since we are looking for z star, the mean is actually 0 and the standard deviation is 1. Okay, so let's put it in the calculator. So let's clear second quit. So if I go to second vars and then pick number 3 inverse norm, you see how here, because we are using the calculator on the computer, and it's very clever. This is the wizard, and it will ask you what's the area. The area is 0.995, right? Area to the left, and the mean is 0 because it's a standard normal distribution, and then standard deviation is 1, right? This is how we can calculate the critical value. So the critical value is 2.576, round to the 3 decimal places. Sweet. Okay, one more. So Elena wants to build a one sample Z interval to estimate what proportion of computers produced at a factory have a certain defect. She chooses a confidence level of 94. A random sample of 200 computers shows that 12 computers have the defect. So they want us to find Z star. So I always draw. Drawing helps. Okay. So 94%. Now just assume that 94% confidence interval is symmetrical this way, and this is 0.94, which makes I'm left with zero point 0.6, right? And then I divide by 2 because I have two areas here that have similar or identical area. So zero point 0.6 divided by 2 is this is 0.3, and this is also 0.3, right? So this is my positive z star, this is my negative z star, and this is a standard normal curve. So again, second vars, we go to inverse norm, right? I need three things. I need my area to the left, I need my mean, and I need my standard deviation. So area to the left of z star here. So it's 0.94 plus 0.3, which is 0.97, and the mean is 1. Sorry, mean is 0, standard deviation is 1. So 0.97. So here, second vars, go to number 3, inverse norm, 0.97. Standard deviation, mean is 0, standard deviation 1. So the z star is 1.88. Voila! Okay, do one more. Okay, one more. Oh, I need a tissue. Elise, I hope this is pronounced as Elise. Elise made a one sample Z interval for proportion and used the critical value of 1 point. So they give you the critical value. They give you Z star. That's a critical value. So what confidence level did she use? Okay. So, let's draw. Maybe this will make sense. So let's draw a standard normal distribution. Now we know that this is 0, right? The mean is 0. And if this is 1.405, sorry, 1.405, and here is negative 1.405. So we know that we want to know what's the confidence, right? What's the confidence level? What is here? What is the area inside here? Um, the easiest thing to do is, if you do this, it's actually a very quick way to find the answer. So you go to normal, right? CDF. Okay? And how do you get to normal CDF? We go to second, and then we go to bars, and then we pick number 2. Anyway, so there are 4 things that you need. 4 things that you need. One is the lower bound, which is right here, because if z star is 1.405, the opposite of it, right? The negative 1.405 is on the other side. So this is negative 1.405, right? What is the upper bound? 1.405. What is the mean? Mean is 0, standard deviation is 1. So negative 1.40. So if you go to second bars, you go to number 2, upper bound is negative 1.405, and then upper bound will be 1.405, positive number. Mean is 0, standard deviation is 1. So it's about 84%. Okay, so hopefully this makes sense. Let me know if you have any questions. Thank you very much, and look forward to the next video. Bye.